This is the last video of dynamics. So after this video, the entire questions from kinematics and dynamics from the book of irodov has been covered in this channel. So look them up. Okay, each and every questions has been covered. Nothing is left. So although this video is 2 hours long, it is little lengthy, but it will give you a clarity of concept of the entire Coriolis force, and it will help you in a lot of way. So although the video is long out here, just watch it till completion. Okay, it will be helpful in your preparation. But that's it. What this question is saying is that there is a circular disc. Okay, and this disc is rotating about an axis passing through the edge with angular velocity omega. That means this disc is not rotating about the center, it is rotating about one of its side. That means the axis of rotation is this one. That means after some time the disc will be like this, after some time the disc will be like this. Okay, and from the perspective of someone sitting on this axis of rotation, okay, this person who is sitting on this axis of rotation, okay, sees a particle at the farthest point of the disk. See, at the moment when the particle is at the maximum distance from the rotation axis, this is the rotation axis, and maximum distance from the rotation axis is the other edge of the disk. So at this edge, there is a particle. Okay, okay. At the moment when the particle is at the maximum distance from the maximum distance from the rotation axis, the resultant of inertial force acting on the particle in the reference frame fixed to the disk turns to 0. Okay, now see what the question is trying to say. This particle is moving with velocity v. Okay, and the net force acting on this particle is equals to 0 according to someone sitting on this axis. Okay, the net force acting on this particle is equals to 0. So that means what? The total forces acting on this particle is equals to 0. Okay, so whenever our observer is rotating, there are two forces that is acting on the particle. One is the centrifugal force, but m omega square into r. Out here, r is the distance between the axis and the particle. Okay, where distance between the axis and the particle is twice the radius of the disk. See, distance between the particle and the axis is twice the radius of the disk. And there is another force that is acting on this particle when we have a rotating frame of observer, and that is the Coriolis force. And what is the formula for Coriolis force? Formula for Coriolis force is minus 2 omega cross v into m. Okay, so this particle, see, omega cross v will be acting in this direction. Use your right hand three finger rule. Okay, and minus of vector in this direction is nothing but vector in this direction. So our Coriolis force would be acting in this direction, which is equals to 2m omega v. Now the question is saying the net force acting on this particle or acting on this particle is equals to 0. So if the net force acting on the particle is equals to 0, that means Coriolis forces or these forces is equals to centrifugal forces. So 2m omega v is equals to m omega square into 2r. Okay, m and m got cancelled. Omega and 2 got cancelled, or our velocity of the particle is equals to omega r, or r is the radius of the disk. This velocity was seen by a person sitting on this axis. Okay, now the first part of the question is find the acceleration of the particle relative to the center of the disk, relative to the center of the disk. Okay, because you might have a confusion, sir, if he is seeing no acceleration out here, that means there should be no force, or no, if there is no force out here, there should be no acceleration. But the question is saying a person sitting out here is seeing no force. What would a person sitting on the center of the disk see this particle as? Okay, will he see this particle experience any force or not? Okay, so now let's change our frame of, or let's change our observer to the center of the disk. Now, before understanding what happens when we change our frame of reference to the center of the disk, let's understand the few concept of rotating motion. Motion. Okay. Suppose there is a disk. Okay. It is rotating about any axis. Suppose it is rotating about this axis with angular velocity omega. Okay. And a person is out here. Okay. Any particle he sees with any velocity, that means if this particle is moving with velocity v downward with respect to this frame of reference, okay, that means any observer on the disk, okay, all observer on the disk at anywhere at any point in the disk, okay, will see this particle moving down with velocity v. Okay, doesn't matter where the observer is situated. And one more thing, if there is a circular disk, okay, suppose it is rotating about any frame of axis, let the axis be out here or out here or out here, anywhere, okay, is the axis of rotation. Any two points will rotate with angular velocity omega with respect to each other. That means suppose this particle or this disk is rotating with angular velocity omega. Okay, now let us take point A and point B. Okay, okay, this what I'm trying to say is this point A and B, okay, point B will rotate around point A with angular velocity omega. How? See, after certain time, what will be the orientation of the disk? The orientation of the disk will be this one. It will go on the top. Okay, this is our rotation axis omega. Where will be the point A? Point A will be out here. Point B will be out here. Now look closely. See, after some time, what will happen? A will be looking up. Okay, say our frame of reference is at point A. Okay, A will be looking up after some time. Then after certain time, what will happen? The disk will go like this. Okay, the disk will reach out here, and the rotation velocity will be omega in this direction. Let's look at the configuration of A. A would be out here and B would be out here. See, A would be looking at B like this. So what I'm trying to say is, if you follow the particle A and B, okay, see, if I draw this schematic of only A and B in one direction, okay, in one diagram, see the first position or in this position, A and B is somewhat like this. Okay, I'm shifting my frame of reference to observer A. A, B. This is our observer. Okay, at the second position, okay, this is our A, this is our B. Okay, at third position, this one, the observer B or observer A, observer B. Okay, so can you see? Similarly, at fourth position, observer A, observer B. So can you see? With respect to A, even B is rotating with angular velocity omega, because B will come back to the same position after one complete rotation of the cycle, no? Or after one complete revolution, only B will come back to the same initial spot. Okay, so from frame of reference of A, even B is rotating with angular velocity omega. What I'm trying to say out here is, if any particle moves with velocity v with respect to a rotating frame, doesn't matter where you sit in the rotating frame, all the particle will move with velocity v. That means all the observer will see the same velocity. Okay, and the second point I'm stating is that the first point is this one, and the second point I'm stating is that if any disk is rotating with angular velocity omega, okay, any two point on the disk will rotate with angular velocity omega with respect to each other. Okay, doesn't matter where the points are. Understood? These 2 points are making out here. Okay, now let's look what happens when you shift our frame of reference at the center of the disk. Okay, that means what? A point out here is also rotating with angular velocity omega. Okay, and this observer out here is also seeing this particle move with velocity v downward. Okay, so this entire disk, this point in the disk, is rotating with angular velocity omega with respect to someone sitting on the center of the disk, and this particle is moving with velocity v. Okay, so according to these two observer, okay, what was the velocity v? The velocity v was omega r, fair and fine. But according to a observer sitting on the center of the disk, there will be centrifugal force, of course, from the from observer sitting at the center of disk, at the center of disk. Okay, and this equation was from observer sitting at the axis, sitting on the axis of rotation, on the axis of rotation. Okay, so from the observer on the center of the disk, what was the velocity of this particle? The velocity of the particle was equals to omega r. V is equals to omega r. Okay, what is the centrifugal force acting on the particle? M omega square. Now the twist comes out here. We should take r or 2r. According to this observer, this particle is rotating with omega, no, according to him, and the distance between the particle and the observer is only r. So out here we take r. Similarly, Coriolis force, where Coriolis force is nothing but 2m omega v. Okay, fair and fine. What is v out here? V is nothing but omega r. V is nothing but omega r. So if I take the net force which is equals to 2m omega v, 2m omega v minus m omega square r, which is equals to 2m omega square r minus m omega square r, which is equals to c. If you substitute v is equals to omega r, it will be 2m omega square r. If you substitute these values, you will get this value. So 2m omega square r minus m omega square r is nothing but m omega square r. Okay, so the acceleration of the particle, okay, relative to the center of the disk is nothing but m omega square r, or inside the, or it is inside this, uh, in this direction. Okay, this is equals to m omega square r, where r is the radius of the disk. Now the second part of the question is, find the dependence of inertial force on the distance of the rotation axis. That means if the particle was, instead of getting situated out here, if the particle was out here, or the particle was out here, or the particle was out here, moving tangential with velocity v, okay, wherever the particle was, okay, doesn't matter wherever the particle was, how does the inertial force, or how does this total force, means will this force get cancelled, or will there be any total force? Okay, will there be any net force, or will the net force get cancelled? So the question is asking, find the net force of the particle, find the net force on the particle if this particle was not situated out here, oops, not situated out here, but instead out here, or out here, or out here, or out here. Okay, but to find the net force from the observer of person sitting on the axis. Okay, the second question is from the perspective of observer sitting on the axis. Understood? So let's do our calculation again. Now the second part of the question says that this particle, okay, instead of being situated out here, was situated at any point in the circumference of the disk. let's say this point, and it was moving tangentially with velocity v. Okay, where v is equals to omega r. Fair and fine. Now what the question says is that the dependence of F inertial on the distance from the rotation axis. Okay, that means what? What is the total inertial force acting on it as seen by outside frame of reference? So can I say the total pseudo force acting on this particle as seen by this frame of reference is equals to total inertial force as seen by outer frame of reference? Because to support this pseudo force, the outer force would be seen that as inertial, no? Understood? Inertial force means nothing but in mechanics you say no, net force is equals to mass into acceleration. Okay, and if you change your frame of reference, this net force minus ma is equals to 0. This becomes pseudo force in moving frame of reference, whereas this becomes inertial force in normal frame of reference. So inertial force is nothing but pseudo force in static frame of reference. You'll understand this in this chapter only. In theory, your teacher must have explained to you in a detailed manner. So what I'm trying to say out here is the total pseudo force acting on this particle, the total pseudo force acting on this particle from this frame of reference, from this frame of reference is equals to total inertial force acting on this particle from outside frame of reference. Understood? Now what is the total pseudo force? The first pseudo force would be centrifugal acceleration or centrifugal force, where centrifugal force is equals to m omega square r, m omega square r, where r is the distance between the axis and the particle. So let that distance be x, where x is nothing but the distance between particle and the axis. Okay, the second force out here would be Coriolis force, and what is the value of Coriolis force? Minus 2 omega v cross m. So if you do omega cross v, omega is outward or towards you, v is rightward. So omega cross v would be a vector in upward direction. Okay, so minus of omega cross v would be a vector in downward direction, that is perpendicular to the velocity. So anything that is perpendicular to the velocity, that means is perpendicular to the tangent, and perpendicular to the tangent, that is normal, also always passes through the center of the circle. So the Coriolis force would be how much? 2m omega v, where v is equals to how much? Omega r. V is equals to omega r as seen by this frame of reference. I've explained it a little bit before. Okay, so if I rectify this, okay, instead of v I'm substituting v by omega r. I'm substituting v by omega r. Now if I check this one, this would be 2m omega square r. So this would be 2m omega square r. Now what I'm doing out here is I'm bringing this 2 with r. Okay, I'm bringing this 2 with r. That means m omega square into 2r. M omega square into 2r. Just algebraic manipulation. Okay. Now total force or total pseudo force, okay, is nothing but this vector m omega square x. Okay, that is acting along this line, because this particle is rotating around this axis, no? Will be rotating around this circular path. Okay, around this axis. Okay. So m omega square x plus the Coriolis force, which is m omega square 2r. Okay. So total pseudo force is equals to m omega square x vector plus m omega square 2r vector. Out here, can I say m is scalar quantity, and although omega is a vector quantity, however omega square is a scalar quantity. Why? Because square of any vector is nothing but a scalar. For example, v dot v is nothing but v square or half mv square, that is a scalar quantity. Okay, so out here, if I take m omega square common, it will be nothing but x vector plus 2r vector. Okay, now see properly what is x vector. X vector is nothing but a line of this length in this direction. Okay, what is 2r vector? 2r vector is nothing but a vector along this length. Okay, the length of the diameter along this direction, that is passing through the center of the disk. Okay, so if I add these two vectors, first vector x and 2r vector, 2r vector, okay, what would be the addition of this vector plus this vector? Can I apply triangle law of addition? First vector, second vector, the resultant vector would be a this vector. Okay, the resultant vector is nothing but the tail of first vector to the head of second vector. So this is our resultant vector. Now it is property of a circle. Okay, in circle, in mathematics there is a concept. Okay, you take any diameter, okay, and you attach two lines to the circumference. That two line will make a 90-degree angle. Doesn't matter where you join it. You can join it out here also. Even this will make a 90-degree. You can join it out here also. Even this will make a 90-degree. Okay, you can join it out here also. Even this will make a 90-degree. So any two lines that is passing through the ends of diameter and joining at any other point in the circumference will always make a 90-degree. Okay, so by that parameter, this angle is also 90-degree. Understood? Now check carefully. What is the resultant? What is the magnitude of this resultant? Can I say this and this are perpendicular and base, and this is nothing but the hypotenuse of this right angle triangle? So x square plus resultant square is equals to nothing but hypotenuse square, or x square plus resultant square is equals to hypotenuse square. So what will be the resultant? The resultant will be nothing but hypotenuse square minus x square. So the magnitude of this vector is nothing but hypotenuse square, which is nothing but 2r whole square minus x square, because I have to find out the magnitude of this one, no? And the direction of this vector is already this direction. And how did I find out this vector? This vector is nothing but the resultant of this vector and this vector by triangle law of addition. Okay, which is nothing but 4r square minus x square under root. This is the magnitude. So total pseudo force or total inertial force as seen by outside frame of reference. I'm seeing the magnitude, or I'm writing the magnitude of this pseudo force is equals to m omega square, which is a scalar quantity, and the magnitude of the force is nothing but, or magnitude of the addition of force is nothing but 4r square minus x square. Sorry, magnitude of addition of the length vectors. Okay, so this is our net pseudo force as seen by this frame of reference, or net inertial force as seen by outside frame of reference. Okay. Acha, this question is similar to the question we have done on Earth. Okay, but instead of Earth, a sphere, this sphere is rotating about this axis with angular velocity omega, where omega is equals to 6 radians per second. Okay, omega is equals to 6 radians per second. Fair and fine. Now in this sphere, what happens is, on top of this sphere, there is a small ball of mass 0.3 kg. Okay, and this ball starts rolling down. After rolling down, it gets detached from the sphere. Okay, the question is asking, find out the centrifugal force and the Coriolis force at the moment of detachment. So whenever detachment comes up, or whenever any body gets detached from any body, okay, what is the necessary condition? Okay, the necessary condition for detachment is the normal contact force is equals to 0. So necessary condition for detachment is normal contact force is equals to 0. Okay, now look out here. This is the ball, or this is the sphere, not ball, sphere, and top of this sphere there is a ball out here. Okay, okay. Initially the velocity of this ball is equals to 0, and this sphere is rotating with angular velocity omega. Fair and fine. After a while, the ball, let's say the ball detaches out here. Okay, and while detaching, the velocity of the ball is v. Okay, we need to find out the velocity v. I have to find out this angle theta. Okay, then only you can find out the Coriolis force and the centrifugal force. So at the point of detachment, how do you evaluate this one? So you evaluate this one by drawing a coordinate axis normal to the tangent and along a tangent. So if you take all the component of force along this grid and this grid, okay, both these grid are perpendicular to each other, okay, and normal contact force is along this line, which is equals to 0 at the time of detachment, we'll get all the remaining force. Now to analyze this force, we'll see from the frame of reference outside, okay, from ground frame of reference. Now you might have a doubt, sir, is the sphere rotating? The sphere is rotating, so why aren't you seeing our frame of reference from out here? Okay, the ball will also exert or experience a centrifugal force, no? So you're not taking into account of centrifugal force when you're seeing from outside. Okay, for that I have an answer. See, in the question, a thing is mentioned, smooth sphere. See this line, smooth sphere. Okay, smooth sphere means what? This sphere is frictionless. Okay, that means what? That means this ball won't be interacting with the sphere, doesn't matter the rotational velocity. Just imagine like this. Okay, suppose there is this sphere, okay, and on top of this sphere there is an air cushion between this ball and this sphere. Okay, a air cushion is there. Understood? Air cushion means the ball is not in directly contact with the this sphere. Okay, now this ball is falling like this. Will it matter how fast I rotate this sphere? No, because the air cushion is only helping the ball to move along with the sphere. No, sorry, the air cushion is only detaching the ball from the sphere. Okay, so if I make this 100 radians per second or very fast, the ball will fall with the same velocity. The ball will detach from the sphere with the same velocity. If I make it 0 radians per second, if I make this 0 radians per second, the fall will again fall with same velocity. So it doesn't matter the angular velocity of this sphere. Okay, the velocity during detachment will be same. Why? Because this sphere is frictionless. Okay, or just imagine the same scenario with the air cushion between this ball and this large sphere. Understood? So that's why I'm not taking account into centrifugal force. Okay, even if I take account into centrifugal force, what will happen? This part of centrifugal force, we'll see the ball will follow weird trajectory. Okay, and to explain that motion, it's very difficult. So to simplify the thing, we just let the ball rotate along with it and see from outside frame of reference, because the friction force is not acting with the ball. No, so let's take this ball, let this sphere rotates with angular velocity omega. Okay, out here only two forces will act. One is the normal contact force, second one is the gravity force. Okay, and during detachment, there is normal contact force in this side and mg force is acting downward. Okay, and we take this component of mg along this direction and this direction. Okay, what is the component of mg along this direction or normal to the tangent? Mg cos theta, because this angle is also theta. Okay, parallel lines, this line and this line are parallel, so if this angle is theta, this angle is also theta. So can I say, see, this is moving in a tangential orbit with velocity v. Okay, and what is the acceleration of this ball? The acceleration of this ball is centripetal acceleration, because this ball is moving along a circular orbit. No, see, while falling, this ball is moving along a circular orbit, so centripetal acceleration is equals to, in this direction, which is equals to v square by r, or v square by r. So can I say mg cos theta minus n is equals to m v square by r, where r is the radius of the sphere. Okay, r is the radius of the sphere. Fair and fine. During detachment, what is the value of normal contact force? 0. So mg cos theta is equals to m v square by r. Okay, m and m gets cancelled. So v square is equals to gr cos theta, or v square is equals to gr cos theta. Now again I need to find out the value of cos theta. So for that we'll use work energy theorem. So from this frame of reference, if you use work energy theorem, okay, or work done by all the forces is equals to change in kinetic energy. Let's say during the break off, the kinetic energy is v. So half mv square final kinetic energy minus 0 initial kinetic energy. Why 0? Because out here the velocity of the ball is equals to 0. Okay, is equals to work done by gravity force plus work done by normal force plus, is there any other force acting on this body? No. See, work done by normal force will always be equals to 0, because at every point the displacement is perpendicular to the force or normal force. That's why work done by normal force will always be equals to 0 in this case. Now what is the work done by gravity force? Work done by gravity force is nothing but force of gravity into this much distance. This much distance is nothing but r minus r cos theta. Okay, if you take r cos theta, it will get this much, and r minus r cos theta is nothing but this much, and mg into this much distance is nothing but work done by gravity force. So it is nothing but mg into r minus r cos theta. Okay, if I analyze this properly, okay, or if I just modify my diagram, not diagram, equation, mg r minus r cos theta, I'm just writing this upward. Okay, mg, I'm taking r common, 1 minus cos theta. Okay, I'm erasing the down part, then I'm erasing 0. Okay, m and m will get cancelled. Okay, let's see what is the equation we get. V square by 2, I can take this 2 to the right hand side, so it will get 2 and this will get cancelled, or v square is equals to 2gr 1 minus cos theta, or v square is equals to 2gr 1 minus cos theta. Okay, now out here you have got equation number 1, v square is equals to gr cos theta. This is equation number 1. Out here you have got equation number 2, v square is equals to 2gr cos theta. If we solve equation number 1 and 1 2, we'll get the value of cos theta. Okay, so let's solve equation 1 and equation 2. Now when we solve this two equation, we get, see, v square is equals to gr cos theta and v square is equals to 2gr 1 minus cos theta. So can I say gr cos theta is equals to 2gr into 1 minus cos theta. Okay, gr and gr would get cancelled. So out here what do we get? If gr and gr gets cancelled, we get cos theta is equals to 2 minus 2 cos theta. If we bring that minus 2 cos theta to the left hand side, we'll get 3 cos theta is equals to 2, or cos theta is equals to 2 by 3. So out here our angle, okay, when the ball breaks off from the surface of contact, out here when the ball breaks off, okay, theta is nothing but cos inverse 2 by 3. Now what we need to do is find out the centrifugal force. See, find out the centrifugal force. See, this sphere is rotating with angular velocity 6 radians per second. Okay, so this sphere is rotating. So this ball will experience a centrifugal force, and centrifugal force is a pseudo force which will only depend upon the omega or velocity, not angular velocity of the sphere. It does not depend upon the velocity of this ball. Okay, so at this moment when the ball is breaking off, let's see, if I see, okay, if I see from the frame of reference, okay, doesn't matter what the velocity of this particle is, this ball is breaking off. Okay, and the sphere is rotating about this axis. When the sphere is rotating out here, can I say, according to a observer sitting on the sphere, the ball will be rotating around this axis. Okay, so the centrifugal force would be directly outside this line, or outside this line of radius r. Okay, just imagine if the velocity is zero out here, what would happen? A observer out here would see this ball rotating around this circle. Okay, doesn't matter what the actual velocity of this particle is from the frame of reference of ground, centrifugal force is always dependent upon the omega of the this sphere, or omega or rotational velocity of the frame, into distance of the particle from the axis. It has nothing to do with actual velocity of the particle. Okay, however, Coriolis force has to do with the velocity of the particle as seen by frame of reference of the sphere. Okay, centrifugal force has nothing to do with the velocity of the particle as seen by frame of reference of the sphere, and the centrifugal force would be directly opposite to this line r. Centrifugal force would be directly opposite to this line. So if I draw this sphere in 2D, okay, out here is radius r, out here is radius r. The ball is slipping out here. Okay, when theta is equals to cos inverse 2 by 3. See, can I say this ball as seen by the frame of reference of someone sitting on the sphere is rotating around this axis. Okay, that means this ball is rotating around this circle. This ball is rotating around this circle. So the centrifugal force would be along this line, or m omega square into r, where r is the radius of this circle. Okay, let me make this little bit neat and clean. Now see, okay, if this is r, or radius of the sphere, this is angle theta, this is r, this is angle theta, what is small r? Can I say r cos theta is this much distance, and r sin theta is nothing but this much distance? So r is nothing but, or small r is nothing but r of sin theta. Okay, or m omega square r, f centrifugal is equals to m omega square r into sin theta. Now you have already derived cos theta is equals to 2 by 3. So what is sin theta? See, if you simply write theta, okay, cos theta is nothing but base by hypotenuse. So 2, 3. If you apply Pythagoras theorem out here, okay, 9 square minus 2 square is equals to, sorry, 3 square minus 2 square is equals to 9 minus 4 is equals to 5. Okay, so sin theta is nothing but under root of 5, sorry, under root of 5. So out here sin theta is nothing but under root of 5 by 3, under root of 5 by 3, which can also be written as under root of 5 by 3, which can also be written as m omega square r whole under root of 5 by 9. Understood? So this is the value of centrifugal force out here. Now the second part, what is the Coriolis force? See, the Coriolis force will however depend upon the velocity of this particle as seen by this frame of reference. Okay, so first you need to find out what is the velocity of this particle as seen by this frame of reference. Now see, a particle out here was moving opposite to y-axis, okay, with velocity v, as seen by someone on the ground frame of reference. Okay, so using these two equation, we have to solve for v. Using these two equation, you find out the value of cos theta, which is equal to 2 by 3. Now if you substitute cos theta in either of the equation, we'll get the value of v. So let us substitute cos theta is equal to 2 by 3 in the first equation. V square is equals to gr into cos theta. Cos theta is nothing but 2 by 3. Okay, or v square, or v is equals to under root 2 by 3 gr. Okay, so v is equals to under root 2 by 3 gr. Fair and fine. Now see, Coriolis force. What I'm trying to do, what is my main objective out here? My main objective is to find out the Coriolis force. The formula for Coriolis force is minus 2 omega cross v into m. Okay, and this v out here is the velocity of the particle as seen by the frame of reference of the rotating sphere. That means the velocity out here should be, or the velocity out here should be with respect to the sphere. Okay, however, the velocity v is equals to root 2 by 3 gr, okay, under root 2 by 3 gr is seen by someone on the ground, isn't it? Remember our derivation. This velocity is from the perspective of someone seeing on, means seeing this velocity from the ground. So how do I transfer this velocity, or how do I modify this velocity so that it becomes from the perspective of someone who sees this particle from the rotating sphere? Okay, now assume, okay, just for a little bit time, imagine this particle was moving with zero velocity as seen by someone. Okay, that means this particle what out here was floating on the top of the sphere, and the sphere was spinning out here, okay, with angular velocity omega, which is equals to 6 radians per second. What I want you to imagine is, instead of v is equals to 2 by 3 gr, imagine the particle was floating out here as seen by this guy. Okay, okay, so if the particle was floating out here, the velocity would be zero out here. Fair and fine. So how would a person sitting inside the sphere see the velocity of the particle if the velocity of the particle was zero? See, velocity as seen by someone on the sphere. Okay, this is nothing but velocity as seen by someone on the sphere. Okay, I'm changing the color to green so that you understand the difference between this velocity and this velocity. Okay, so this velocity is from someone seeing from the perspective of sphere. Okay, so if the velocity out here was zero, okay, by some ground reference, see, an observer inside the sphere, an observer inside the sphere, okay, would be rotating, okay, and he would see this particle moving in backward direction, no, with omega r. See, this circle, okay, the observer sitting on this sphere, the observer sitting on this sphere, okay, the observer sitting on this sphere, how would he see? He would see this particle moving in this circle, okay, opposite to the direction of omega. If omega is anti-clockwise, you would see this particle rotating clockwise in this circle. Okay, so whenever you are shifting our velocity from ground frame of reference to sphere frame of reference, what is happening is the velocity of the particle, okay, plus omega r. Okay, why omega r? Because if the velocity out here was zero, okay, if the velocity out here was zero as seen by someone, okay, the velocity of the particle as seen by someone sitting on the sphere would be omega r in the opposite direction, where r is the distance from the axis. Okay, understood this much? See, I'm explaining it again. Okay, imagine someone, or imagine someone sitting on the ground. Okay, imagine yourself sitting on the ground and you are seeing a particle floating out here. Okay, it has no velocity, velocity is equals to zero. Okay, for some time just imagine velocity of this particle is equals to zero, you are sitting on the ground. Okay, your friend however is sitting on the top of this sphere which is rotating with angular velocity omega. Okay, he'll keep on rotating, no, he'll keep on rotating. If you call him and ask, acha, what is the velocity of this particle as seen by you, he'll say this particle is rotating clockwise in this circle. Why? Because he himself is rotating anti-clockwise. According to you, he himself is rotating anti-clockwise, and his particle is rotating clockwise. Understood? So this guy or your friend will see this particle rotating anti-clockwise in this circle. So it would have an at that instant or at this instant, okay, at the beginning instant or at the instant when the particle flew off, okay, what is the velocity of this particle? The velocity of this particle is omega r, opposite to or tangential to the direction, okay, of this circle, okay, omega r, omega r tangential to the direction of this circle. And what is tangential to the direction of this circle? It is nothing but the x-axis, okay. This particle will be rotating anti-clockwise in this axis. And what is this omega r? Opposite to x-axis, okay, where tangential direction was, where this tangential direction was y-axis. See, the tangential direction is y-axis, okay. The normal to tangent is z-axis. The normal to tangent is z-axis, which will pass through the center of the sphere, z-axis. And this is nothing but x-axis. X-axis in this diagram is inside the plane of paper. See, x-axis is inside the plane of paper. This is positive x-axis. So your omega r vector or omega r vector is in negative x-axis, no? See, positive x-axis is in this direction, velocity is in opposite to the positive x-axis. So this omega r would be opposite to positive x-axis or is equals to minus I cap. Why minus I cap? It is opposite to the positive x-axis, okay. So whenever you have any velocity or whenever you have any particle, okay, sitting on the uh, top of a sphere, okay, from the frame of reference of the sphere, whatever is the velocity of the particle, that will be added along with the omega r at that point. Understood? That means if the particle out, if the actual velocity of the particle out here was 0, 0 plus omega r. If the actual velocity of the particle was root 3 by 3 gr, root 2 by 3 gr plus omega r. Okay. So whenever you are shifting our frame of reference, we must add this value of omega r minus I cap. Understood? Now what was the actual velocity of the particle as seen by someone on the ground? The actual velocity of the particle was in this direction, which was equals to under root 2 by 3 gr, under root 2 by 3 gr. And what is the direction of this particle, or what is the direction of this particle as seen by him? Opposite to y-axis or opposite to y-axis. What is opposite to y-axis called? Minus j cap, minus j cap. So the velocity of the particle as seen by someone sitting on the sphere, sitting on the sphere, and the sphere is itself rotating with angular velocity omega, okay, is nothing but minus uh, root 2 by 3 gr minus j cap plus omega r minus I cap. Understood? This is the velocity of the particle as seen by someone sitting on the sphere, that you have to substitute out here. Understood? Okay. So this is the first thing you must need to understand, that we must substitute this value of v out here. Okay. Now one more thing. This omega cross v, no? So omega is also a vector. Fair and fine. And what is the direction of omega vector? Omega is an axial vector which will be directly pointed upward. Fair and fine. Now my question is, how do I explain or how do I write omega in this coordinate system or in this coordinate system? See, if I just shift this vector out here, okay, this vector will be somewhat like this, omega pointing upward. Okay, now see, what was this angle called? This angle was nothing but theta, no? Remember, see, this angle was nothing but theta, where cos theta is equals to 2 by 3. Okay, now see, this line and this line are parallel to each other, and this is the intercept. Okay, this line and this line, omega and this line, are parallel to each other, and this is the intercept. So this angle is theta, this angle will also be theta, no? This angle will also be theta. Understood? So can I write omega vector as how much? I'm writing omega vector in this coordinate system x, y, and z. Okay, so omega vector is nothing but omega, okay, cos theta in z direction and omega sin theta in y direction. So omega sin theta in y direction and in positive y direction. Okay, omega sin theta in positive y direction. What is positive y direction called? J cap, plus omega cos theta in positive z direction. What is positive z direction called? K cap. See, the omega out here would be upward. Understood? And the component of omega in x-axis is 0 because it is making a 90-degree angle with x-axis. Why? Because x-axis is perpendicular to this plane of screen. Understood? Okay. Now I have to apply Coriolis force. Okay. Coriolis force is equals to minus 2 omega cross v into m, where v is equals to this value and omega is equals to this value. Okay. So I'll copy this formula, this equation on the next page, or these two variables on the next page, and solve it. Understood? See, velocity is equals to this value and omega is equals to this value. Now focus at r out here. What was r? R was nothing but the radius of the circle or radius of this circle. Out here r is nothing but this value. R is nothing but this value. R, where r is the radius of the circle. And what is the relation between radius of the sphere and radius of the circle? Radius of the circle is nothing but radius of the sphere into sine theta. Okay, so out here we'll use r is equals to r sine theta. Okay, for capital R is the radius of the sphere. Now what we'll do is we'll try to find out the Coriolis force. Now I'll focus this value, I'll copy paste this value and these two values on the next page, and I'll do the calculation. Now out here, okay, omega cross v is nothing but see, Coriolis force is nothing but minus 2 into omega cross v into m. So the first thing we'll try to do is find out the value of omega cross v. So omega cross v is equals to I j k. Okay, I j k. Achha. The first value you have to find out is of omega. Omega has no I value. The j value is, it has no I value. The j value is omega sine theta or omega sine theta. I'm writing sine theta as s theta. Okay, plus omega cos theta or omega cos theta. Now in the second line, I'll try to write down the velocity of v. Okay, it has omega r sine theta as I value. So it is nothing but omega r sine theta, and it will be minus omega r sine theta. Why? Because see, the minus out here would come outside. So it is nothing but minus omega r sine theta. What is the j value? J value is nothing but minus root 2 by 3 gr. So minus root 2 by 3 gr. Okay, and what is the k value? There is no k value out here. So we'll find out the value of omega cross v. If you multiply this one, or I assume you know how determinants work, so I'll just do it out here. Okay, so out here when you do the cross product, it is nothing but plus I into cover this I section, cross multiply these two. Omega sine theta into 0 is 0, minus this minus and this minus gets plus 2 by 3 gr into omega cos theta. So omega cos theta into 2 by 3 gr. Then minus j. Then you have to cover this one and this one, cross multiply the remaining this one, minus of this one and this one. So 0 into 0 is 0, minus and this minus gets converted to plus, and omega r sine theta into omega cos theta becomes omega square r sine theta cos theta plus k. Now cover out this one. Okay, this is plus minus plus. Now cover out this row and this column, sorry, this row and this column. So k into cross multiply these two, 0 into anything is 0, minus this minus and minus becomes plus, and omega sine theta into omega sine theta is nothing but omega square r sine square theta. So the Coriolis force would be nothing but this value into minus 2m. So F Coriolis is nothing but this entire value, okay, this entire value, into minus 2m. Now if you notice carefully, this Coriolis force is a vector quantity, okay, drawn on this Cartesian coordinate system. Now what we need to do is find out the magnitude of this vector. And how do I find out the magnitude of this vector? Suppose any vector is given, okay, or any force is given, F is equals to AI, or any quantity into I cap plus Bj plus Ck. How do we find out the vector of this or magnitude of this vector? Magnitude of this vector is nothing but under root of a square plus b square plus c square. Okay. Similarly, we'll do the same thing out here. F Coriolis is equals to this vector. So how do I find out? I have to square this vector plus this vector plus this vector and under root. Okay. So we'll do that on the next page. Therefore, magnitude of F Coriolis is F Coriolis, okay, is nothing but, see, I'm taking minus 2m common and taking it outside. Okay. Or see, if you're taking or talking about the magnitude, okay, this minus will get multiplied by all these three values, okay, and whole square of that minus will become plus, so if I take this 2m outside or minus 2m outside, this minus will disappear. 2m, understood what I'm doing? See, this is that pure mathematics. This is nothing to do with physics. If you multiply minus 2m with these three vector quantities, okay, this minus will go inside this one. And while finding out magnitude, you have to square the entire term, this square plus this square plus this square. So irrespective of negative or positive, the output will be positive only. So and again, when you take common and take it outside, it will be positive only because the minus will disappear by taking the whole square. Understood? Into under root of, okay, out here this square, this entire term square, okay, is nothing but omega square cos square theta and 2 by 3 gr, okay, okay, plus this entire term square, this minus will get converted to positive, so it is nothing but omega 4 r square sine square theta into cos square theta, okay, plus this entire term whole square is nothing but omega 4 r square into sine 4 theta. Okay, if you under root this one, we'll get these values. Now let us solve it. And what was the value of cos theta? The value of cos theta was 2 by 3. Okay, you already derived it. And therefore sine theta is equals to under root 5 by 3. This also I have derived. Okay, if you take a triangle, okay, if you draw theta out here, this is 90 degree. So if cos theta is equals to 2 by 3, then this perpendicular would be 9 square minus 2 square is equals to 5 or under root 5. So sine theta is equals to under root 5 by 3. Okay, now let's substitute. If cos theta is equals to 2 by 3, so what is cos square theta? Cos square theta is nothing but 4 by 9. Okay, similarly out here, sine square theta. Sine theta is root 5 by 3, so sine square theta would be 5 by 9. Similarly, cos square theta. Cos square theta is 4 by 9. Sine to the power 4 of theta. Okay. Sine theta is under root 5 by 3. So under root 5 by 3 whole square to the power whole square is nothing but 5 by 9 whole square, or is equals to 25 by 81. Okay, so this is nothing but 25 by 81. Okay, so let's erase this one. Now we'll just be substituting all these numerical values in the original equation. Okay, see this one. Okay, see. Now if we expand this one, or if I write this, substitute the value of cos theta, sin theta out here, we get this value. Now see, 4 2s are 8, 9 3s are 27. So this would become 8 by 27. So this is nothing but 8 by 27. Similarly out here, 5 4s are 20, 9 9s are 81. Okay, so 20 by 81. So this is nothing but 20 by 81. Okay, and this is 25 by 81. 25 by 81. See, this is omega 4 r square 20 by 81, omega 4 r square 25 by 81. So these two are the same thing. No, these two can be added. So 20, if you take 81 as common, okay, 20 plus 25. So this entire thing can be compressed as omega 4 r square 45 by 81. Why? 20 plus 25 is equals to 45. So this entire thing would be, this entire two things would be 45 by 81. So 45 by 81. Okay. Okay. Now what would we do? Achha. Can we take omega 4 r square common? I'm taking omega 4 r square common. Okay. So divide both the term by omega 4 r square and omega 4 r square. Okay. I'm also taking 9 common from both. Achha, first let's deal with omega 4 r square. So this entire term would get cancelled. Okay, so this would be 45 by 81, and this omega square would get cancelled with omega 4 and become omega square. R would get cancelled with r square. So if I write this neatly, this would disappear. This omega 4 would become omega square. Let me write it. And r would become, this would be the value you would get. Okay, now let me write this little bit neatly. G by omega square r 8 by 27. So this is nothing but, let's write it down out here. 2m under root by g by omega square r 8 by 27 plus 45 by 81 bracket into how much? Omega 4 r square. Okay, now if I take 9 common, okay, this term would become 9 and this term would become 3. So similarly 3 and 9, 3 and 9, fair and fine. And we know that 9 5s are 45. So this would get cancelled by 5. So it get only remaining 5 out here. Okay. Now if I take this term outside the square root, I would get 2m omega 4 will become omega square, r square would become r, by 9 under root would become 3 under root of 5 plus 8 by 3 g omega square r. So this is the value of Coriolis force. See this question. Okay, in this question the earth is rotating with angular velocity omega, which is equals to 2 pi radians in 24 hours, which is the natural velocity of earth. Okay, a train out here, okay, is moving along the meridian. See, a train moves along the meridian. That means the train moves along this line. Okay, this is the meridian line. Okay, these are the latitude lines. The train is moving along this line. That means what? At any instant, the velocity of the train is along y-axis. Fair and fine. Okay. At that instant, the latitude is 60 degree. See, the latitude is 60 degree. 60 degree north. That means this angle or phi is equals to 60 degree. Okay. And the velocity of the train is along y-axis because it moves along the meridian. The velocity is 54 kilometer per hour. So you have to convert 54 kilometer per hour into meter per second. How do you convert that? You multiply by 5 by 18. 18 3 is 54 and 5 3 is 15 or 15 meter per second. So 54 kilometer per hour is basically 15 meter per second. Now the question is, okay, what is the Coriolis forces? What is the lateral forces? But we have to find out the Coriolis forces acting on this train. Okay, if Coriolis is nothing but minus 2 into omega cross V or minus 2 into omega cross V into M. Okay, what is the direction of omega? The direction is of omega is upward. Omega is an axial vector. V is along y direction. Okay, so somehow we have to find out the angle between omega and V. Okay, see out here. Okay, if omega is this angle, if omega is this line, okay, what is the angle between omega and V? The angle between omega and V will be this line, okay, or this much angle. Now how much is this much angle? If you draw a straight line out here, this line and see, this line and this line makes a 90-degree angle. This is 60 degree. So this angle must be 30 degree because sum of angles of a triangle is equals to 180 degree. See, this line and this line forms a triangle. Okay, and this is a straight line. Okay, this much is understood. Now what is the angle between y-axis and this radius? The angle between y-axis and radius is nothing but 90 degree. Why? Because this radius is normal to the sphere. Okay, and y is nothing but tangential to the sphere. So angle between normal and tangential is also 90 degree. So this angle is 90. Okay, this angle is 30. So this angle should be how much? 60 degree. Understood? Okay, so this much angle is 60 degree. So the angle between straight line and tangential line is 60 degree. So angle between omega vector and tangential velocity vector is nothing but 60 degree. Okay, for those of you didn't understand, this line, assume this line, this line, and this line, and this line in a single plane. All these lines, okay, are in a single plane. Understood? Just rotate this sphere to align this line, velocity line, this straight line, this line, and this line in a single plane. So you'll get the angles. So now that we know that the angle between velocity vector and omega vector is 60 degree. So it's simple. Okay, or minus 2 omega v sine 60 into m. What is the value of sine 60? Root 3 by 2, or minus 2 omega v m into root 3 by 2. Okay, or f Coriolis is equals to minus root 3 omega v m. Okay, this is one of the way of doing this problem. The second way of doing this problem is, see, this velocity, okay, can be component into the vertical vector and the horizontal vector. The horizontal vector would be perpendicular to this line. So assume this line Okay, assume this line and this line to be parallel. Okay, what is the component of this velocity v along this line? Okay, the velocity v along this line is nothing but, see, if this is 60 degree, this is nothing but 30 degree. Okay, this angle is 30 degree. Why? Because this line and this line makes a 90 degree angle. Okay, now one more thing, component of velocity along this vertical line or along w, okay, would be v cos 60, fair and fine. But the Coriolis component of force due to that velocity or v cos 60 would be 0. Why? Because the component of velocity along this line, the angle between this line and this line is 0. So every component of velocity along this line would be equals to 0. Understood? Okay. Now the Coriolis forces would only be generated due to the component of velocity along this line. Is that understood? Okay. So if Coriolis or alternative one, alternative, if Coriolis is equals to minus 2 omega into v cos 30. Okay, and the angle between component of velocity along this line and this line is 90 degree. So into sine 90, into sine 90, and sine 90 is automatically equals to 1. Okay, component of Coriolis force due to this vector or this straight line vector would be 0, because for this vector the angle between this vector and this vector is equals to 0. So sine would be 0 out here and sine 0 is 0. So there is no component, there is no Coriolis force due to component of velocity along this vertical line. There is only Coriolis force due to component of velocity along this line. Understood? Okay. Now what is the direction of Coriolis force? Just assume the velocity is along this line or component of velocity along this line. Apply right hand three finger rule. Omega is upward, index finger should be along this line. Okay, and what, the Coriolis force is nothing but opposite to x or along this line. Omega cross v is along this line, so automatically minus of omega cross v would be along x axis. So if Coriolis is along this axis, if Coriolis, because minus omega cross v is along this line. Okay, now see, the train was out here. Okay, the second part of the question is saying what should be the velocity of the train, or in which direction, with what velocity should the train move such that the total pseudo force acting on this train is equals to 0. This is the second part of the question. Okay, now what are the two pseudo forces in rotating frame? There are only two pseudo forces in rotating frame. The first one is centrifugal force and the second one is Coriolis force. Okay, so centrifugal force does not depend upon the velocity of this train as seen by this observer. It only depends upon the position of this body from the axis of rotation. What is the direction of centrifugal force? See, if you draw a radius, okay, that means this line and this line are parallel to each other. This is the radius r, radius of this circle. Okay, this is the radius r. What is the direction of centrifugal force? Directly opposite to the radius, which is equals to m omega square r. This is the value of centrifugal force. Fair and fine. Okay, now what is the value of r? See, if I know this value phi to be 60 degree or latitude angle to be 60 degree, okay, can I say radius of the sphere r, okay, into cos 60 is nothing but small r. Why? Because if this is 60, this much angle is 30, this much angle is 90, and this much angle is how much, 60 again. So r cos 60 is equals to small r. So capital R cos 60 is equals to small r. So centrifugal force, if centrifugal is equals to m omega square r cos 60 r, which is equals to r cos 60. Okay, because the centrifugal force would be, because we are effectively taking this as the rotational plane and this is as the axis of rotation. Okay, now what is Coriolis force? See, for the net pseudo force to be zero, okay, Coriolis force should be acting in this direction. This should be the direction of Coriolis force, okay, which is equals to 2 omega v. Okay, omega is acting upward, or omega is a vector acting upward. Okay, what should be the direction of Coriolis force? See, F Coriolis is equals to minus into 2 omega cross v, okay, into m. Now see, what should be the direction of omega cross v? See, if you do v, okay, opposite to x-axis, directly opposite to x-axis, use your right hand three finger rule. Okay, omega is upward, v is opposite to x-axis, directly opposite to x-axis. Omega cross v is along this line or along m omega square r. So minus of that vector is nothing but along this line. Understood? So if the body is moving directly opposite to x-axis, okay, along this line with whatever velocity that you have to find out, okay, then the Coriolis force would be directly opposite to the centrifugal force. Acha, out here one term is missing, the term of mass is missing in Coriolis force. Okay, out here. Okay, so in order for the net pseudo force to be zero, m omega square r should be equals to 2 omega vm. Okay, m and m would get cancelled, omega and omega square would get cancelled. Okay, r is nothing but r cos theta, sorry, r cos 60, or omega r cos 60 is equals to 2v. Okay, or v is equals to omega r cos 60 divided by 2. What is the value of cos 60? The value of cos 60 is nothing but 1 by 2. So omega r by 4. So the velocity of train should be directly opposite to the x-axis with velocity omega into radius of earth divided by 4. Okay, okay, this is the earth. I'm just tilting the earth, or I'm just tilting this diagram to the right hand side. Okay, like this. Rotated the earth in this direction, or I've rotated the diagram of earth in this direction, but omega is in this direction. Okay, now in this question what is being said is that a ball is out there, okay, in the equator, in this equatorial plane. Okay, it falls down at height h, from height h. Okay, as it falls down, the direction of velocity v would always be downward, no? And due to this velocity v, okay, what will happen? There will be a Coriolis force acting on this body. If Coriolis is equals to minus 2 omega cross v into m. Okay, so what will happen is, see, if you apply omega cross v, omega is rightward. Okay, if you apply three finger rule, if you apply the thumb towards omega, which is rightward, v towards down, omega cross v would be a vector inside the plane of paper. So minus omega cross v would be a vector outside the plane of paper. So Coriolis force is acting outside the plane of paper. Okay, and this Coriolis force would keep on increasing. Why? Because this velocity would keep on increasing as the ball goes down, no? So if I draw this diagram, or if I draw this equator out here, okay, out here the earth is rotating with angular velocity omega. Okay, so omega vector is towards you. Out here ball is dropped to the velocity v, okay, from height h, and it will hit the equator. Fair and fine. Now see, as it hits the equator, no, what will happen? A Coriolis force would act. And what is the direction of Coriolis force? If we apply same three finger rule, the direction of Coriolis force would be towards left. Okay, F Coriolis. And due to this force, what will happen? There would be a displacement of particle, or there would be a deviation of particle. That means the ball will fall somewhat like this. Okay, the question is asking what is the deviation of this particle, or what is this much distance? What is the deviation of this particle? Okay, you have to find it out. See, if Coriolis force was not there, the particle would fall out here. Due to Coriolis force, the particle shifted by this much distance. The question is asking what is this deviation? So how do we solve this one? We take a parameter of time. That means as the particle falls down, okay, what will happen? The velocity is increased. So let's take the vertical component of velocity. V is equals to ut, sorry, V is equals to u plus at. U plus at. Okay. Initially, when the particle was at height h, the initial velocity of the particle was equals to 0 because the particle was dropped from here. A is nothing but acceleration due to gravity. So the velocity is equals to g into t. Okay. Now take this component of velocity. Okay. The particle started out here and it is moving out here. If I apply x is equals to ut plus half at square, x is equals to ut plus half at square. Okay, this equation is for this component of motion. Okay, and this equation is for this component of motion. Now one thing we're taking advantage of is that the time taken to fall this much distance, or time taken to fall due to gravity, is equals to the deviation caused due to Coriolis force. Understood? The time taken to fall due to gravitation force is the time taken for the deviation. Okay, now see, we need to find out the acceleration. You also know that force is equals to mass into acceleration. And what is the component of force in this direction? The only component of force in this direction is nothing but Coriolis force, which is equals to 2 omega v into m. Okay, is equals to mass into acceleration, where v is a variable and this variable v is given by gt, where v is nothing but gt. V is nothing but downward component of velocity which varies according to time t. Okay, so can I write 2 omega gt m is equals to mass into acceleration, or mass gets cut, or acceleration in x component, or acceleration in x component is equals to 2 omega gt, 2 omega gt. Fair and fine. Now see, I cannot use this formula. I have made a mistake out here. I cannot use this formula. Why? Because this acceleration is not constant. See, acceleration has a parameter of time. So I cannot use x is equals to ut plus half at square. Okay. So what can I use? I can simply use acceleration is nothing but dv by dt. Acceleration is equals to dv by dt. Okay. That means initial velocity out here to velocity out here. Okay. Acceleration is nothing but 2 omega gt, which is the x component of acceleration, is equals to dv by dt. Now if you integrate this one, or 2 omega gt into dt is equals to dv. Okay, if you integrate it, 2 omega gt square by 2 is plus some constant is equals to v. Cancel out 2 and 2, or omega gt square plus some constant is equals to v, and this v is in this component. Okay, now see, let's apply the boundary condition to find out the value of constant. At t is equals to 0, at t is equals to 0. That means when the particle was out here, the initial component of velocity in this direction was equals to 0. So v is equals to 0. See, when the particle was out here, okay, there was no Coriolis force, and initially the particle wasn't projected with any this horizontal velocity, no. So the particle initial horizontal component of velocity is equals to 0. Okay, so if you apply t is equals to 0 and v is equals to 0 in this equation, our value of constant is nothing but 0. Okay, so at time t is equals to t, or at time t is equals to t, okay, velocity is equals to omega g t square. Okay, now I have to find out at what time does the particle fall down from height h. Okay, if we simply apply x is equals to ut plus half at square, x is equals to ut plus, sorry, y is equals to ut plus half at square, y is equals to ut plus half at square in this component or in vertical component. Okay, y is nothing but h. So in vertical component acceleration is constant, no. U is nothing but 0, a is nothing but g. So h is equals to half gt square, or uh, gt square, or t is equals to 2h by g under root. This is the value of time when this particle reaches the ground. So time when the particle reaches the ground in this vertical component is the time when the particle reaches out here or in this position. Okay, so out here you have to find out the time in which velocity becomes this value. Okay, now that we have obtained the equation of velocity and the time at which time taken to fall down, time taken to cover distance h, I can simply apply dx by dt, or v is equals to dx by dt. Okay, v is equals to dx by dt in this component. What is the this component of velocity? Omega gt square, or v is nothing but omega gt square, okay, is equals to dx. Dx is nothing but elemental distance in this direction, dx by dt. Okay, if we integrate this one, omega gt square into dt is equals to dx. Okay, and if we solve this one, what will happen? I'm just erasing this boundary condition out here. Okay, or I'm solving this equation out here. Okay, so that it doesn't become cluttered. Omega g t square dt is equals to dx. If we integrate it, it would become omega g t cube by 3 into t cube by 3 plus constant is equals to x. Okay, if you put boundary condition at t is equals to 0, okay, at t is equals to 0, the x component of displacement was equals to 0 because the particle started from out here, no. So if you put t is equals to 0 and x equals to 0, the value of constant becomes 0. So x is equals to omega g t cube by 3. Very and fine. And what is the time in which the particle reaches down? Time is equals to 2h by, or under root 2h by g. So x component of velocity, or the deviation, is equals to omega g by 3 into t cube, or 2h by g. Under root can be written as 1 by 2, 1 by 2 into 3. Okay, this under root is written as 1 by 2 and this cube is written as 3. Okay, 1 by 2 into 3 is nothing but 3 by 2, 3 by 2. Okay, so out here the deviation, okay, is equals to omega g by 3 into 2h by g to the power 3 by 2. Understood? Now see, some of you might have questioned Sir, what about the centrifugal force? Okay, isn't the centrifugal force also acting? Obviously the centrifugal force is acting. The direction of centrifugal force is upward out here. Okay, but here in this problem we decided to ignore the effect of centrifugal force. The effect of centrifugal force is to reduce this velocity. Okay, as this goes down the centrifugal force would decrease and the v would means the rate of change of increase in velocity would be little bit lower. But the effect of centrifugal force in this problem is neglected. Similarly, when you do gravitation problem or kinematics problem, do you take into consideration the effect of Coriolis force? No. So in kinematics, you do not take into consideration of Coriolis force. Okay. Why? Because the deviation is very low compared to this deviation is very low. Okay, why? Because this omega, the value of omega is also very low. 2 pi divided by 24 hours, it's not a very large value. 2 pi is nothing but 2 into 3.14 or 6.28 something. Okay, divided by 24 hours is nothing but 24 into 3600. So omega becomes a very less value. Understood? So until and unless this height has very large value like 500 kilometer or 400 kilometer, you wouldn't see a deviation or noticeable deviation. Understood? And if height has such large value, the value of gravitation constant wouldn't be constant. Okay, we'll learn in the few or upcoming chapters of gravitation. Okay, because this height was very low, we have assumed the value of gravity, acceleration due to gravity is equals to constant. Okay, so the effect of centrifugal forces out here is neglected. It doesn't mean that centrifugal forces does not exist out here. Understood?